Hey everyone, moving on with our graph and transformations, we'll be looking at the reciprocal graphs. So there are two reciprocal graphs that you guys will need to know, which are the 1 over x and 1 over x squared. For this video, we'll be looking at 1 over x, alright? So let's begin by looking at the function 1 over x itself. Because now we have x as a denominator and the numerator is simply 1, there's a rule in math where you cannot divide by 0, right? And because of that, you know that x cannot be 0, right? And that is the whole idea of fractional algebra. Any fractions, right? Your denominator cannot be equal to 0. And in this case, x cannot be 0, all right? And from here, we can kind of sketch the graph. So let's break this into two portions, right? Because x cannot be 0, we look at the portion where x is positive, and then we look at the portion where x is negative. All right, so let's consider x bigger than 0. What happens? So again, let's take on some values. So let's use x equals to 1, we have 1. Then x equals to 2, we have half. X equals to 4, we have 4. All right. So what do you notice? You notice that the graph is decreasing, right? For x equals to 1 onwards, right? And what you also notice is actually very important, is that if you look at the change between x equals to 1 to x equals to 2 and x equals to 2 with x equals to 3, you notice that 1 to half, you decrease by half. Half to 1/4, you decrease by 1/4. So what do you notice is that the graph is decreasing at a decreasing rate, right? It decreases from half and then decreases by 1/4. So it's a decreasing graph, but it's at a decreasing rate. Now, because x is not necessarily 1, 2, 3, not necessarily be whole numbers or integers, x can also be half, right? So let's take a look at what happens when x equals to half. We get 2, right? You notice that as x gets smaller and smaller, your value gets larger and larger because, well, if you divide by a smaller number, you result with a greater number. And as such, right, what a trick is that if you notice, right, if x is between 0 and 1, you will get bigger values than 1. If you get x bigger than 1, you will get values that are less than or equals to 1, all right? So again, if you look at the change, let's say from 1/4 to half is 2, and then from 2 to 1 is 1. So what you notice is that it is decreasing at a decreasing rate as well. And you know that as x gets very, very, very small, so very close to 0, it is very, very, very large. And the idea is that because x is very, very, very large when x is very, very, very small, 1 over x is very, very, very large, we can say that it is approaching infinity. All right, so when x approaches 0, this is for the H2 math people, we know that 1 over x approaches infinity, right? It's a very large value. So because of that, your graph would look something like this for your positive x side. And when x approaches infinity, when x approaches a very large value, 1 over a very large value would simply be very close to 0. All right. And because of that, for the H2 math students, you have your asymptotes at x equals to 0 and y equals to 0. Now let's consider the negative portion for x. All right. So now we have x less than 0. So let's take some values again. All right. So we have x equals to -1. We know it's -1. X equals to -2 is basically minus half. And then we have -1/4 for x equals to -4. Now what you notice is that as you go towards negative infinity, your graph is increasing, right? Because it's getting less negative, right? -1 to -half is plus half. -half to 1/4 is -1/4 is plus 1/4. So it's increasing at a decreasing rate, all right? For x bigger than for x less than -1, -2, -4. Now we look at x equals to -half. You get -2. X equals to -1/4. You get -4. And what you notice is that it's actually very much similar to your positive x, where if you notice, if x is less than -1, so more negative than -1, you get x less than 1, x greater than -1 and smaller than 0. Same thing for your x that is more than -1, so greater than -1, you have x greater than Actually, no, x less than minus 1 because it's now more negative than minus 1. All right, so minus 1, minus 2, minus 4. As such, same logic as just now. If x is very, very, very close to 0, you get a very large number. But because it's negative, it is a very large negative number. So you start around over here. As x approaches super negative, a very large negative number, 1 over a very large number, you know it's very, very, very small, close to 0. As such, you'll get close to 0, but remain at a negative portion. As such, your graph will look something like this for negative x. Okay, let me try to draw this properly. Okay, fantastic. All right, so something like this. All right, of course, if you want to be more specific, let me just draw it from here. It looks something like this. All right, actually, yeah, you get very, very close to 0. Let me just try to get this right. Okay, finally. All right, so this will be the y equals to 1 over x graph, where the logic is that if x is very large, 1 over x will be very small. If x is very small, it'll be very, very large, right? It'll be depending on whether it's positive or negative. All right, so that is the graph of 1 over x.